Hello everyone, it's Evren again, and we are again hosting another great guest in our Turkey Java community event. Uncle Bob is with us, Robert is with us, and he's famous with his really good books, and I'm one of his fans, and I'm really excited to host him here. So I don't want to talk so much. Robert, the stage is yours. So the show is yours, and thank you again being with us.
Thank you. It's a pleasure being here, and welcome everybody. I know it's probably in the afternoon where you are. For me, it's relatively early in the morning. It's about 9 a.m. And the talk I'm going to give you today is a talk that I have given in many places and many times over the years. It's a talk called Expecting Professionalism. I'm going to share my slides. Let's see if I can get that to happen with you. Now, there we go. I think I can use this tool. And now you should see my slides on your screen, and I hope that they are black with yellow letters.
Exactly, Robert. Exactly.
Because they're not on my screen. But that's okay. All right. So, Expecting Professionalism is the name of this talk. In this talk, I am going to transport you into a fantasy world where I am your new CTO. Now, this is not a world in which you want to live because I'm not a very good administrator. I'm actually a programmer, and that's what I want to be. I don't want to be anything else. I don't want to run a company. I don't want to run a business. I want to write code. I want them to find me one day with my nose stuck between the keys of the keyboard in half done with some program that I was working on, right? And I don't want that to be anytime soon, by the way. That's what I want to be. But for the sake of this particular talk, let's assume that I am your new CTO, your new Chief Technical Officer, and I am going to tell you what I expect of you. I presume that most of you out there are programmers or are somehow strongly related to the programming industry, and therefore I'm going to communicate my expectations. As you hear these expectations, you will hear them with two ears. One ear will be the ear of the customer and the manager and the everyday person. And what that ear hears will be perfectly normal, acceptable, makes perfect sense. How could it be any other way? The other ear that you will hear this with will be the ear of the programmer. And the ear of the programmer will hear something insane, impossible. No way this could be done. And I will leave it to you to balance those two ears as you hear what my expectations are. Primarily, this is a talk about professionalism. And before I get into the expectations I have of you, let's define this term. Do we have a profession? And the answer to that is no, we don't, because there is nothing that we profess. We do not profess any particular standards, any particular disciplines, or any particular ethics. We are a trade, but we are not yet a profession. We need to become a profession. That is something that is going to be necessary for our continued ability to thrive. And here's the reason why. Look around the room, wherever you are at the moment, and count the number of computers that you can see or that you are near. Now, I have a lot of computers near me. You can see a number of them behind me. That's my flight simulator back there. And on the wall, you can see some old front panels of some very old computers. But there are a whole bunch of computers around me that you cannot see. I've got an iPad over here, and I've got my laptop that I'm using to talk to you. And I've got, oh, gee, look at this. I've got an old HP 35 calculator, or actually, this is a modern HP 35 calculator, which is a mock-up of the old HP 35 calculator. And I've got, oh heavens, I've got all kinds of computers surrounding me. I've got my my watch. How many processors do you think are in this watch, right? This watch has more computing power than the spaceship that went to the moon. Here's my AirPods. My AirPods, right? And I open up the AirPods, and what do we see? We see a little earpod there and another little earpod there, and then, of course, the case. All of them have their own little processors in them. There's at least 3 processors in here, probably more than that. And again, the computing power right in here is more than the computing power that went to the moon in the 1960s. Yes, we are surrounded by a vast number of computers. If you look on my walls, you will see computers. You can't see them over here, but I've got an intercom over there, definitely a computer in that. I've got a smoke alarm up on the ceiling, definitely a computer in there. I've got clock on the wall, definitely a computer in there. You should go up to my kitchen. And I imagine your kitchen is the same. Maybe you have a microwave oven. There's a computer in that microwave oven. Maybe you've got an oven, a stove, probably a computer in that. You might have a refrigerator. There's probably a computer in that. You might have a dishwasher. There's probably a computer in that. Do you have a washing machine for your clothes? There's a computer in that. Or a dryer for your clothes? Yes, there's a computer in that. Do you own a car? I own a couple of cars. Do you know that a modern car has over 100 million lines of code in it? And most of that code is in the entertainment system and the global positioning system, the GPS system. But a fair bit of that code sits between your foot and the brake. There are if statements sitting between your foot and the brake. You'd kind of like to think that there's a metal cable going from the brake pedal to the brake calipers, but nowadays there are if statements in there. And wouldn't you like to know what those if statements say? Wouldn't you like to know how those if statements were tested? How many people have been killed by the malfunctioning of the software in their car? And the answer to that is nearly 100. A very large number, many dozens of people have been killed by the malfunctioning of the software in their cars, and many, many more have been injured. Imagine you're driving down the highway and all of a sudden your car is out of control because the software in the car decided it would throw a null pointer exception. You and I are killing people. We didn't get into this business to kill people. You and I, we're programmers, we're geeks. We didn't get into this to kill people. Most of us got into this industry because we wrote an infinite loop that printed our name on a screen once, and we saw our name go up the screen, and we thought, yes, the power, that's what I want to do for the rest of my life. We didn't get into this to kill people, but now we are killing people, and we are destroying fortunes and destroying lives. Software sits at the center of everything that goes on in our society. In our modern society, everything is mediated by software. Think of the things that you do in your daily life, and almost everything has software right smack in the middle of it. You can't cook a meal without software being involved. You can't watch TV. You can't make a phone call. You can't drive your car. You can't buy anything. You can't sell anything. You can't pass a law. You can't enforce a law. You can't get insurance. You can't file a claim. There is literally nothing you can do in the modern world without software sitting right in the middle of it. A lot of us have software running to monitor our sleep. So even when we're not awake, there is software in the midst of everything we do. Our civilization depends on software. You and I rule the world. Other people think they rule the world, and then they hand the rules to us, and we write the rules that execute in the machines that govern everything. And we are not professionals. And that should terrify everyone. The society does not yet quite understand just how exposed they are, just what kind of risk this is. We don't really understand it very well, but the day will come. You can imagine, right, the disasters that have already occurred, right? The number of horrible situations that have happened because of malfunctioning software. I could talk about the cars that killed people some more if you wanted to hear more about that, but we could also talk about, the software in the 737 MAX. That was a bad one, right? It just killed several hundred people because of malfunctioning software in the airplane. Yes, I know there was a hardware component to it, but the software played a very large role in those two horrible accidents. And think of the economic damage that was done after that. And then perhaps you've heard of the company Knight Capital. Maybe you've heard of this, maybe not, but this was a New York trading firm about 8-9 years ago, where some software guy did some dumb thing and the company lost $500 million in 45 minutes. And, the company went under because of that. They just lost that entire fortune. I won't go into the mechanism for how that happened, but it was just a software guy doing something dumb. You've done something dumb, probably. I've done something dumb. It's pretty easy when you're doing software to, do something a little bit dumb, and the repercussions can be pretty severe. One day, probably not too long from now, some poor software person is going to do some dumb thing and kill 10,000 people at a shot. And it's not hard to imagine what that might be anymore. You think for about 5 minutes and you'll come up with a number of possible scenarios, right? And when this occurs, and it will, right? It's got to occur because the odds are almost overwhelming at this point. When that occurs, the politicians of the world will rise up, as they should, in righteous indignation, and they will point their fingers right at us. You'd like to think that they won't point their finger at you, right? You'd like to think that they're going to point their finger at your managers, right? Or your company. But no, that's not what's going to happen. Did anybody watch the testimony of the CEO of Volkswagen North America when he went before the Congress of the United States and testified about why the Volkswagen had software in it that was cheating the Environmental Protection Agency's testing machines? You would literally drive these Volkswagens up onto a testing harness, and the software in the Volkswagen would detect the fact that it was on a testing harness, and it would change the parameters of the engine so that it would not emit noxious fumes into the air. And then when you drove the car away from the test device, it would reconvert the engine to spit noxious fumes into the air because, of course, that made it a more powerful engine. The CEO of Volkswagen North America was asked the question, "How, sir, could you have let this happen?" And his answer was, and I quote, "It was just a couple of software developers who did it for whatever reason." That finger came right down to us. And you can bet that's where that finger is going to be, and not without justification, because it will have been our fingers on the keyboard. It will have been 1 or 2 or 3 of us, or maybe 20 of us, or maybe 50 of us who wrote the code that killed 10,000 people. And so when the politicians point their finger at us and ask us the question, "How could you have let this happen?" we'd better have an answer for them. And if our answer is, "Oh, my boss told me it had to be done on Tuesday," if that's the answer we give them, then the politicians of the world will hang their head in disgust and walk away, and they will begin to legislate. They will pass laws. They will tell us what languages we have to use, and what hardware we have to use, and what platforms we have to use, and what frameworks we have to use, and what processes we have to follow, and what books we have to read, and what classes we have to take. And we will all wind up working for the government as civil servants. This is not a future that I want to live in. I want to get there first. I want to get there before the politicians of the world get there. And the way we do that is to become professionals, to adopt a profession, to profess a set of disciplines, a set of standards, and a set of ethics. The expectations that I am about to read to you help us to define what those standards are. Perhaps they will give us some hints about what the disciplines ought to be. And behind it all, maybe they will give us a glimmer of what the ethics ought to be. And with that, here's what I expect. I expect, as your new CTO, that we will not ship shit. This seems to me to be a perfectly reasonable expectation, that we, software developers, will not ship a load of crap to our customers. Now, notice what the programmer ear is saying. The programmer ear is saying, but we have to ship shit. I mean, do you understand our schedules? Do you understand the pressure we're under? Of course we have to ship shit. No, we don't. This is what it means to have a profession. One of the things that we will profess is that we will not ship bad code. We will not ship software that is not up to standards. We will not ship bad software. By the way, nobody wants us to. The other ear heard that statement with a bit of misunderstanding. The other ear thought, well, of course you're not going to ship crap. Why would you ship crap? I mean, nobody wants you to ship bad code. And the programmer ear is now whispering at you saying, well, my manager does. No, your manager does not want you to ship bad code. Nobody wants you to ship bad code. And then you have to ask yourself, well, then why do we do it? Now, I have shipped bad code in the past when I was younger. I have shipped bad code, definitely have, because the pressure was so high. The schedules were so terrible. The deadlines weighed so much upon me that I had to ship bad code until I finally realized one day that, no, actually, I didn't have to ship bad code. I could have said no. And I know. It's hard to say no. I know. You think, well, if I say no, I'll get fired. Probably not. Probably not. But if you do get fired, well, that's maybe not a company you want to work for then, huh? Anyway, that's the first expectation of what it means to be a professional programmer. But we should go on. I expect that we will always be ready. Now, this is going to take a little explanation. Some of you have probably used an agile process. Many of you, perhaps, have used an agile process. Agile is all the rage, We're all supposed to be doing agile now. Okay, well, if you are doing agile, what that means is that you are working in short cycles. Some people call them sprints. Some people call them iterations. It doesn't matter. These periods of time are usually about 1 or 2 weeks long. And at the end of every sprint, if you wish, at the end of every sprint, what are you supposed to have done? What state is the software supposed to be in at the end of every sprint if you are following an agile process? And the answer to that is that the software is supposed to be deployable. Deployable. You should be able to deploy the software at the end of every sprint. You may not deploy the software. That will become a business decision. The business may decide that they don't want to deploy the software, possibly because it doesn't have enough features yet. But from a technical point of view, from your point of view, if the business decides they want to ship the software in its current form, you're perfectly happy with that. You've done all the testing, you've done all the documentation, everything is done. Yes, you can't log in, you can only log out, but that's a business problem, not a technical problem. From your point of view, log out works just fine. So if they want to ship it with only log out and no way to log in, well, that's up to the business to do. But from a technical point of view, everything is ready. That's what I expect. I expect that at the end of every sprint, we will be ready to deploy. I consulted for a company 20 years ago at the very beginning of the Agile movement. And this company was a company that made a word processor for lawyers. Lawyers need their own kind of word processor because they don't write normal language, right? They have to have their own special kind of way of writing. So this company built word processors for lawyers. And when we taught them how to do Agile, they learned, and they learned very well. And they started a 2-week-long process. Every 2 weeks, they would finish their jobs, and they would make software that they believed was deployable. And they were so certain about that at the end of every 2 weeks, they would burn a CD. Yes, there's a bunch of you out there that have no idea what burning a CD means. But 20 years ago, burning a CD is how you deployed an awful lot of software. They would burn a CD, a compact disc, and then they would take that CD and they'd put it on the top of a stack, which was every other week, right? So all the other sprints. So there's this big pile of CDs in the machine room, one for every sprint. One for every sprint. If a salesperson was going to go out and do a sales call with a demonstration, what the salesman would do is they would walk into the machine room and they would take the top CD off that stack and they would go out and do a demo. That was how certain the sales organization and the technical organization was that the software at the end of each sprint was ready. That's what I expect. I expect you will always be ready. I do not expect that you're going to demand some kind of burn-in period, some kind of stabilization period. You know, stabilization. That's when all the programmers say, we're done, we've got all the code written, and the business says, okay, well, can we deploy it? And then the programmers say, no, God, no, don't deploy it. We need to sit and watch it for 3 months. We need to watch it and see if any smoke comes out. Just run it for a while in a private environment where no customer can see it, and we'll see if it crashes or anything terrible happens. And then if it doesn't crash for like 3 months, then maybe we can deploy it. I don't expect that. I don't expect QA to come roaring in and saying, we haven't tested it. You can't deploy it. We haven't tested it. I expect all the testing to be done at the end of every sprint. All the documentation to be done at the end of every sprint. And the software should be ready to deploy. I expect stable productivity. Stable productivity. Let me explain that to you. Several of you out there have probably already experienced unstable productivity. Unstable productivity works like this. You begin a new project. How fast can you go at the very start when the project is brand new? There's no code out there yet. How fast can you go? Someone comes to you and asks you for a feature, and you think, yes, I can do that feature. And you start to code, and code pours out of every orifice of your body. And within a week or 2 weeks, you have the feature working. And people stand around and they go, oh my God, they got that feature working so fast. Can you get another feature working? Yes, we can. Code, code, code. Come back to that team a year later. Ask them for a feature, right? Ooh, it's going to be tricky. Probably take us 3 months. It used to take you a week or two to do stuff like this. Yeah, but you don't know how complicated this system has become, how tangled, how interwoven. Why, if we touch even a single line of code, all hell could break loose. No, 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 no. It's going to take us months. That's unstable productivity. The productivity goes down with time. I don't expect that. I expect stable productivity. I expect you to go as fast tomorrow as you went today. I do not expect the project to get dirty. I do not expect it to get tangled. I do not expect the code that you have written in the past to impede your future progress. I do not expect that you will build a monster that stops you from making progress. And you can hear the one ear going, well, of course. I mean, why would you build code that would stop you from making progress? And you can hear the other ear going, well, we've always done it that way. I do not expect that you will make a mess. How many of you have brought code up on your screen and the blood drains out of your face as you stare at the code and you realize that it's awful, it's terrible, oh my God, it's just so complicated. And for a moment, a brief moment, something whispers in your ear and says, well, you could clean it. And almost immediately you say, I'm not cleaning it, not me, I'm not going to do that, because you know if you touch that code, you'll break it. And if you break it, it becomes yours. So you walk away. You're not going to be the one to clean that code. Oh no, someone else can clean that code. That's why systems rot. That is the reason that systems degrade with time. Systems degrade with time because no one is willing to clean them. No one is willing to make them better. They're too afraid. The code terrifies them. Now, I want you to think very carefully about just how wildly unprofessional it is to be so afraid of what you have created that you are not willing to make it better. How incredibly irresponsible that is. We'll talk a little bit later about maybe what you could do about that, but I do not expect productivity to decrease with time. I expect productivity to remain stable. I expect inexpensive adaptability. Inexpensive adaptability. What is that? That is the cost of making a change. I don't expect the cost of making a change to be out of proportion with the size of the change. When a customer comes to us and says, you know, we need to make a change, I do not expect that the software developers will go, oh my God, that change ruins everything. It destroys our architecture. It thwarts our design. Oh, it's going to take us years. I don't expect that. I expect that when customers come to us with a change, we look at that change and say, okay, we think we can do that change. I want you to consider this. If your design and architecture do not allow for change, then your design and architecture suck. I mean, because the purpose of design and architecture is to allow change. Software is a compound word. Software is composed of two words, soft and ware. Soft means flexible, ware means product. Software means flexible product. That's why we created software. We created software so that we could easily change the behavior of our machines. Had we not wanted to easily change the behavior of our machines, we would have stayed with hardware. But no, we did want to easily change the behavior of our machines, and so we invented software. To the extent that your design and architecture make the system hard to change, you have thwarted the reason that software exists. The cost of a change should be proportional to the scope of the change. If it's a big change, it's probably going to cost a lot. If it's not a big change, it's probably not going to cost a lot. But who should be the judge? The cost of changing software should be proportional to the customer's estimate of the scope. It's the customer that's going to look, the user who's going to look and say, well, that shouldn't be a big change. And if they say that, it shouldn't be a big change. If your design and architecture has made what they think should be a small change into a big change, well, then there's something really wrong with your design and architecture. I expect continuous improvement. I expect that everything gets better with time. I don't expect that the software gets worse with time. I don't expect that the design will degrade with time. I don't expect that the code gets messier with time. I expect that everything gets better with time. Making things better with time is what human beings do. Nature degrades things with time. That's entropy. Human beings make things better with time. To the extent that your software gets worse and worse and worse with time, you are not behaving as a human being. I'm not going to say what you're behaving as, but it's not a human behavior. Humans make things better with time. So what do I expect to improve? I expect the design of the code to improve. I expect the architecture of the system to improve. I expect the cost of change to go down. I expect the documentation to get better. I expect the graphical user interface to get better if you have one of those. I expect everything to get better with time. I expect you to continuously improve the software. I expect you to continuously improve yourselves. I expect you to learn and get better. And I expect you to take what you have learned and make your products better and make your software better. And listen to the ears, right? The customer's going, well, yes, of course. And the programmer's going, you don't understand. It's so hard. I expect fearless competence. Fearless competence. Now, to explain what that means, I need to explain what fearful incompetence is. Fearful incompetence. Remember I told you about looking at your screen? You see the bad code on your screen. You think, oh my God, I should clean that code. And then the devil shouts in your ear and says, no, don't clean it. If you clean it, you'll break it. If you break it, it becomes yours. Don't touch it. Don't touch it. That is fearful incompetence. It is incompetent because you are now not competent to improve the code. And that incompetence is based entirely on fear. I don't expect you to be fearfully incompetent. I expect fearless competence. How could we achieve this? How could we achieve fearless competence? How could we eliminate the fear of change? I want you to imagine that there is a button on your computer. Doesn't matter which button it is, just some button. When you press that button, some lights blink and some sound comes out, and then eventually a little green light lights up. Within a minute or so, a little green light lights up. And that little green light means that the entire system works as it's supposed to. That there are no bugs, that everything is working exactly the way it's supposed to. Now imagine what you would do if you had that button. You push it, and a little green light lights up. Everything's okay. Little green light means everything's okay. Now, bring that bad code up on your screen again. Listen to your ears. One ear says, you should clean that code. And the other ear tries to tell you to stop, but you think, no. It's not a problem. I can clean this code. It's not going to take me a long time. I think I'll just change the name of that variable right there. It's a better name. I'll just make that, push the button, green. Oh, I haven't broken anything. Okay. This function's a little big. Maybe I should split it into 2 functions. Push the button. Oh, green. Good. I haven't broken anything. Excellent. Oh, this code's getting better. That function that I just made, I think I can put it in this class over here. Push the button. Ooh, red. Put it back, put it back, put it back. Push the button. Green. Okay. Oh, I see what I did wrong. I put it in the wrong place. I should put it over here. Push the button. Green. If you had that button, you would not be afraid. If you had that button, you would be fearlessly competent. How are you going to get that button? How are you going to get that button? There are disciplines out there that will help you get that button. One of those disciplines has a name, and the name is test-driven development. I will leave you to do the research on this. There are other disciplines as well that might be better or might not. I will leave you to do the research on that. I will also leave you with this thought. Not having that button is stupid. You've got to have that button, because if you don't have that button, you will lose control of the code and you will become fearfully incompetent. I expect extreme quality. Of course, you've got the button. I don't expect bugs. When did we decide that bugs were necessary? When did that happen? When did we decide that all systems have bugs? When did we decide that it was acceptable to log our bugs into a computer-driven database? Because there are just so many bugs, we have to have some automated system to keep them all straight and to sort them. When did we decide that that was a good idea? Now, from my point of view, all the bugs in your system should fit on an index card. You should be able to write them all down on an index card, and you should be able to get rid of them within a matter of hours. Because, okay, every once in a while you make a little mistake. Okay, write the bug down and then get rid of the bug. I don't expect a load of bugs. I don't expect a load of defects. I don't expect that to be normal. I expect extreme quality. I expect, and by the way, the word extreme quality, maybe I shouldn't have said extreme quality. I just expect quality. I don't expect defects. And it is not necessary to have defects. Oh, you've got a big system. Is it going to behave perfectly every time? Well, that should be your goal. You might not achieve that goal every time, but you should consider it to be your goal. Because I expect that you're not going to dump on QA. I don't expect you to think, oh, well, I'm just going to write some code and then I'll hand it off to QA and QA is going to find all the bugs. I'll just give it to the testers and the testers will find all the bugs for me. Yeah, that's what I'm going to do. That makes it really easy to write the code because the code doesn't have to work. I'll just hand it off to the testers and they'll tell me what's wrong with it. And then I'll fix it and I'll hand it back off to the testers and they'll still tell me what's wrong with it. I don't expect that. I don't expect us to dump all our problems on QA, because what I expect is that QA will find nothing. When you hand the code off to the testers should find nothing. If they do happen from time to time to find something, we should all be going like, how the hell did that happen? How did a bug get out from us to them? They should never find a bug. In fact, I don't expect QA to really be at the end of the project. I don't think QA should be sitting at the back end testing everything. I think QA should be at the front of the project, specifying how the project behaves. QA should put the quality in up front, not test it at the end. Whose job is it to test it at the end? The programmer's job. The programmer writes the code. Programmer should test the code. And the testing should be Automated. I expect the testing to be automated. The picture you're looking at here is a picture of a QA manager. That's whose hands you see. The QA manager is holding out this document for me to take a picture of. That document is the table of contents for the manual test plan. It is not the manual test plan. It is just the table of contents. Yes, this is a big company. Yes, it's a very big project. And he's got an army of people in India testing his system every 6 months. It costs him $1 million every 6 months just to test his system manually. He's holding this document out to me because the year is 2008. Some of you will remember 2008, the financial crisis that rocked the world, the recession that began, that spanned the globe. He's holding this out to me because he's just gotten back from his boss's office. His boss has just gotten back from the CFO's office. The CFO is cutting everybody's budget by 50%. This guy is asking me which half of these tests he should not run. And I told him, well, doesn't matter which way you cut it. You're not going to know if half your system works. That is the inevitable end result of manual testing. If you do manual testing, you will lose those tests. You may lose them with this mechanism. Right? The accountants might finally come and say, it costs too much to test this. You're going to have to cut your testing. You might lose the tests that way. But there is a much more insidious way that you will lose the tests. And this is a way that people don't detect very often. It happens a lot, but people don't detect it very much. And it works like this. Developers deliver to QA late, of course, because developers are always late. QA is going to have to finish all of their testing on a compressed time scale because we cannot move the shipment date, right? Even though the developers were late, we cannot change the shipment date. So now QA must test the system in a much smaller time than they thought they would have. Well, how do you do that? Well, you do that by not testing everything. You have to do an impact analysis. That's what they call it, an impact analysis. They look at everything that changed, and then they try to test the things that would be affected by that change. Of course, they guess, and they guess that wrong, and so they don't run an awful lot of the tests. They lose the tests. Tests should be automated. That's what we do. We're programmers. We automate things. They should be automated. It's not hard to automate tests. Right? And it's not expensive. I mean, running the tests manually every 6 months, that's expensive. Automating the tests, that's not expensive at all. And then when you automate the tests, you just run them all the time. You run them every night. You run them twice a day. You run them 5 times a day. Maybe you even hook those tests up to a continuous build environment and run those tests every time you check in any code at all. I expect nothing in the system to be fragile. You know those modules? There's always that module that is somehow the dumping ground for everybody. And it's always the module where the bugs are. Yeah, there's always one like that. I don't expect that. I don't expect there to be weak points in the system. I don't expect there to be the dumping ground module where you put all the crap in your code. I don't expect anything fragile to accumulate. I expect that we will cover for each other. I expect that we will behave as a team. Software people use the word team a lot. You've heard of this, right? Software teams. Are we a team? We're a team of software developers. Well, exactly how does a team behave? Imagine you're a team of sports people, moving the ball down the field, right? You're offense and you're kicking the ball or passing the ball and you're moving it down the field. And then one of the players on your team trips and falls. The referees do not throw a flag. The play does not stop. What do the other players do? They change their field positions and they keep the ball moving down the field. They cover the hole for the man who went down, for the person who went down. That's how a team behaves. A team knows how to cover for people when they go down. Now, in a software team, it's the same thing. Bob is the database guy, right? But Bob is on vacation. That should not mean that all the database activity stops, right? Somebody else should be able to come in and continue working on the database. Jim is the GUI guy, but Jim is sick today. Well, somebody else should be able to cover for Jim and continue the work on the GUI that's necessary, right? Pete is the middleware guy, and Pete had a big fight with his wife, and he's sitting over in the corner crying, and he can't get any work done today. Well, somebody's going to have to fill in for Pete until he gets control of his emotions and comes back to work, right? We have to be able to cover for each other. People go down. People become unable to work. It happens all the time, and we need to be able to cover for each other. How would you cover for each other? And in fact, let me turn this around. It is your responsibility to make sure that someone can cover for you. You make sure there are other people on the team that know what you're working on, know where to find the source files, know how to do the builds, know pretty much what you're up to. Now, how are you going to do that? Well, there's a discipline out there. Just make short reference to this discipline. It's called pair programming. Some people will even call it mob programming. Not a bad idea, right? If you want someone to be able to cover for you, why don't you sit down with them at your laptop and work together for an hour on your stuff? And by the way, you could work with someone else on their stuff. You don't have to do this 100% of the time. Some people say, oh, pair programming, I couldn't possibly do that. I need to work alone. Well, you can work alone all you want, right? But you should work with other people enough so that you can cover for them if they go down, or that someone can cover for you if you go down. It is irresponsible of you to leave the team in the lurch when you go down. I expect honest estimates. Honest estimates. Do you know what the most honest estimate is? The most honest estimate is, I don't know. 3 little words, yeah. I don't know. It's the most honest estimate because you don't know. You don't know how long something's going to take. But I don't know is not a useful estimate. We have to be able to make it more useful by describing what we don't know. We need to be able to describe the shape of our uncertainty. It's not just that we don't know. It's that we don't know precisely. But we do know within certain bounds. So the technique that I like to use is this. When someone asks me how long it's going to take, how long is it going to take you to do this? I'll give them 3 numbers. The first number is the best possible case, right? This is the 1 in 20 chance that I can pull it off, right? 5 days. It's going to take me 5 days. There's a 1 in 20 chance that I'll have this done in 5 days. Now that is the estimate when everything goes right. For the whole 5 days, everything goes right? There's no weird meetings. Nobody gets sick. You don't have a fight with your significant other. Your coworkers are always polite. There's no bug in the field that causes you to lose a day. Everything goes right. Then I give them the second number. The second number is the 50% case, right? There's a 50% chance that I'll get this done within the next 10 days. Right? It might take longer than 10 days. It might take less than 10 days, but about even odds that it'll be 10 days. Right? That's called the nominal case, right? And that's when things go as they usually go. Okay, odds are even. Then I give them the third number. The third number is the 95% case. That's the one where, 95% of the time I'm going to get it done by this date. Yep. No, there's a 1 in 20 chance that I'm going to miss this date, because this is the case where everything goes wrong. There's constant meetings. There's new people coming in. There's people quitting. There's bugs in the field. Your wife leaves you. You know, all this terrible stuff is happening to you, and you're going to get this done in 4 weeks. 5 days, 10 days, 4 weeks. Those are the three numbers that I would give them. Or I would come up with some other appropriate numbers. 5%, 50%, 95%. And that gives the managers the shape of your uncertainty. That's fair. It's very fair. It's very, the word I want to use is accurate. It's not very precise, but it's very accurate. Yes, I will get it done. Odds are very good that I'm going to get it done somewhere within this time frame. Managers don't like that. They don't like that. And that's a little bit strange because the job of a manager is to manage uncertainty. And you are providing them the uncertainty that they are supposed to manage. That is their job, after all. They manage uncertainty. That's what management is all about, managing the uncertainty of very complex processes. Right? So you are going to supply them with the uncertainty that is their job to manage. Now, of course, they're going to try to limit that uncertainty. They will put pressure on you to narrow those estimates, to bring them in. They'll put pressure on you to produce a single date. Never give them a single date. Never. Unless you're absolutely certain that you can deliver on that date. You never give them a single date. You always give them a range. Never give them a single date. Every time you give them a single date, you are lying because you don't know you can make that date unless you're damn sure you can. All you're doing by giving them a date is you're telling them a lie. Right? And then they'll come back to you at the end of that saying, well, why didn't you make that date? You said you could. Oh, it was really more complicated than I thought. Doesn't matter. And then watch out for this little trick. Managers will sometimes say to you, well, will you at least try? Now, be careful with that because you will be tempted to utter the words, well, of course I'll try. And that's the wrong answer. The real answer is no, because I'm already trying. How dare you insinuate that I am not trying? I am trying now. We are all trying now, and there's no way we can try harder. By the way, don't say it that way. It probably would be a bad idea to yell at them like that. But be strong. Say, I'm sorry, sir, or ma'am, whatever. We are trying. What you are looking at now is us trying. There is no way we can try harder. The date you're asking is not going to happen. You were hired because you are expected to say no. That may seem strange to you, but you are the ones who know. You are the ones who understand. You are the ones who can judge whether something is possible or not. And if that thing is not possible, you must say no. You will save your company untold millions and millions if you say no at the right time. And one of the reasons you were hired is because you have the expertise to say no when the answer really is no. Now, you should always look for a way to say yes. You know, that's also part of your job. You've got to be creative and hunt for some way to say yes, but sometimes the answer is no, and you have to be able to say that. By the way, I don't want all the new programmers who've only been programming for a year to go run around and say no. Don't do that. Let the senior guys do that. But you senior guys out there, you have to be able to say no, and you have to be able to stand on that. So, sorry, this is not going to happen. So that the managers can then manage the situation the way they are supposedly trained to do. I expect continuous aggressive learning. This goes back to improving yourself. I expect you always to be learning. I expect you to go home after spending whatever time you spend at work, and I expect that you're reading books and studying new techniques, learning about design patterns, learning about solid principles, learning about functional programming, learning about object-oriented programming, learning the history of software. I expect you to be dedicated to your profession. Yes, you all have personal lives. Of course, you have personal lives, and you should engage in your personal lives. But you also have a profession. And a profession is something that needs to be nurtured. It needs to be husbanded. It needs to be taken care of. And the way you take care of your profession is to put personal time into it. It's not a job. It's a profession. It's not a labor. It is a profession, and a profession requires effort. You probably use doctors. I hope you use doctors. You probably don't want to use a doctor who considers their job to be a 40-hour-a-week thing. 40 hours a week, that's all I put into my doctoring, sorry. No, what you probably want to use is a doctor who puts 40 hours in treating patients, and then goes home and reads trade journals, reads medical journals, goes to medical conferences, things like that. Someone who is investing in their career, improving themselves constantly, continuous aggressive learning. One last expectation, the last of them all. I expect you to teach. I expect you to teach those who come after you. One of the problems we've got in our industry is that the new people are coming in at a horrific rate. The number of programmers in the world doubles every 5 years. Did you know that? Every 5 years, there are twice as many programmers as there were the 5 years before. And what that means is that half the programmers in the world have less than 5 years experience. And this will continue to be true as long as we grow at a rate of every 5-year doubling. So you guys who have 10 years experience, teach the other ones, teach the young ones, mentor, teach. By the way, little secret, the best way to learn something is to teach it. Best way to learn is to teach. Take it from a teacher. The best way to learn is to teach. And by the way, if you are teaching, you only have to stay one day ahead of them. It's another little trick of the teacher. You only have to be one day ahead. You seem like a real expert when you're just one day ahead. Teach, communicate, teach each other, teach, mentor each other. And with that, I'd like to thank you for paying attention to this talk. It's a lovely talk that I love to give all the time. It's a passion of mine. And with that, I will turn it over to my hosts. And if you have any questions, you can feed them to the host, and I think they will feed them to me.
Okay. Hello, Robert, again. Thanks for this amazing presentation. It's really nice. Also, I wrote some questions during your presentation. So there is one question, especially when you say continuous learning, continuous aggressive learning. Seda asked it, should we learn multiple languages or technologies from your point of view as a career advice?
Learn as many languages as you can. If you're Java programmers, that's great, but now you need to learn a language that's not Java. You need to learn a language that's not even close to Java. You need to learn a language like, I don't know, what's a language that's not close to Java? Ruby. Learn Ruby. What a lovely little language Ruby is. Learn Python. Maybe you, pardon me. Maybe you're a Kotlin programmer. Well, Kotlin's kind of like Java, but a little bit more restrictive than Java. That's fine. Learn Fortran. Go back in time and learn Fortran. Learn C. If you've never learned C, learn C. There are so many languages out there. Ooh, you know a good language to learn? Learn Forth. Forth. Learn Forth. Boy, that'll blow your mind. And you want a language that'll really blow your mind? Learn Prolog. That's a language that'll take you and twist you sideways. There are so many different languages out there, and they all have a completely different modes of expression. And as you learn every new language, you will understand the language you prefer much better. If you are a Java programmer, as you learn Ruby, you will understand Java much better. Every problem you look at, you will suddenly look at with widened eyes that can see the problem from a very different viewpoint. So absolutely learn new languages. And for most of you, that means you're going to learn them at home. You're going to explore new languages on the weekends and at home. And I'll tell you a little story. I decided I had a project to work on. This is about 30 years ago. Decided I had a personal project to work on. And I had 4 children at the time. 3 children. I had 3 children at the time, and the 4th was on the way. And my wife was pretty convinced that I needed to spend a lot of time at home. So I had to negotiate with her. And the negotiation was I needed at least an hour a day to work on a private project. And she was very gracious. And she gave me the hours between 10 p.m. and 11 p.m. Okay? The kids could all be put to bed. And she would go to bed at 10, and I would go to bed at 11, and I would spend that hour working on my private project. This is the kind of thing that you have to do, right? That you have to take and somehow carve out a period of time for you to improve yourself, take care of your profession, and learn new things. What you definitely do not want to do is be stuck on one language. Languages go through popularity cycles, right? They become popular, and then they start to slide down the popularity curve. That's a very slow process. It takes a long time for a language to slide down. And it would be easy for you to get caught on that slide. But if you go too far down that slide, when the next language comes along, you will not be able to jump onto it. And you will be considered out of date, outmoded, someone who is, well, just not quite the programmer that people thought they were at once. You don't want to go down that slide, right? So you have to be ready. You have to look at those popularity curves. You have to watch them. You have to kind of judge what they're going to do. And then at just the right moment, you jump and you go on to the next language and be ready to do that.
Yeah, it's clearly understood. And also in our profession as software developers, it's really easy to make a continuous improvement day by day. So there are lots of options. As you said, there are lots of languages, technologies. So it's really easy. And I wrote this one. So another question is about your motivation when you are writing the clean code, clean architecture, the books.
Why did I write these books? So I'll start with clean code. This was a very morally difficult book for me to write. I had wanted to write it for a long time, but I did not feel worthy. That's probably the best way to put it. I mean, how can one programmer tell other programmers what to do? And so for a very long time, although I wanted to write the book, I did not feel like I was justified in writing it. I did not feel worthy to write it. And at some point, I thought, well, somebody's got to write this book. And I decided I would write it. And I set my misgivings aside, and I wrote the book. And I made sure in the beginning of the book, I said, look, this is the way I do it. You don't have to do it this way. But, you know, I've gotten a lot of benefit out of following these rules. And that's why I wrote the book. I wrote the book so that everybody else could get a glimpse of how one old programmer learned how to improve the product that he was writing.
Yeah.
Every other
And
book that I've written is based on the same kind of reasoning.
yeah. Also, let me repeat my sentence before the talk from clean code. So we were refactoring last week a code base. So as you say in the clean code, if you comment out the code block, remove it, delete it. And that's so easy in order to reach a clean code. So there is another question from Islam, by the way, how to properly practice a language and get good at it. So how you are going to be a proficient in a language?
How do you get proficient in a language? Well, you write a lot of code in that language, and you probably have to write 2 or 3 or 4,000 lines before you're even moderately proficient. And the best place to do that is at home on a private project, where you've got the freedom to experiment and where the risks are low. The problem with learning a new language at work is that the stakes are very high, the risks are very high, and you will be much more conservative. You won't learn as much, and you'll frankly do a much poorer job. So spend the time at home or at lunch times or on breaks or whatever time you can carve out to learn other languages independent from work. This is true of just about everything we learn, by the way. Every new technique you learn, every new discipline you learn it in a safe environment. Learn it at home, learn it on breaks, learn it at lunchtime, learn it on weekends. Learn it someplace where the cost of an error is low, because you will make errors. And you don't want to be making those errors when the stakes are high.
So practicing side projects is really helpful at that point, as you said.
Yeah.
Exactly. So there is another question from Metin. For the topics that you mentioned during your talk, have you seen these cases in your professional career to just mark all of these, like honesty in the estimations, continuous learning, say to know, agile, and other stuffs?
You mean, have I ever seen that done across the board? Have I seen companies that did all of this? No. and I'm not sure that I ever will, because what I just painted, the picture I just painted, was an ideal picture. It was a picture of how we all hope things could be one day. The reality, of course, is that we're going to have to crawl that way. We're going to have to crawl up that slope. We're going to have to try to get better and better with time. I have never seen all of those principles used all at the same time, because I'm not sure that's even possible. But I have seen some of those principles used 100%. And I have also seen all of those principles used to some extent. And in all of those cases, it was an improvement. It was better. So there's nothing wrong with pointing at the horizons and saying, one day I'd like to be there. And then realizing that it's going to be a long slog before you get there.
So there is another question. This time it's more related to system design, not related to learning different languages, and how we can be proficient in system design or architecture.
How do you get proficient at system design? Well, you design a lot of systems. Design a lot of systems. And then
practice.
When I was young, when I was 18 years old, I started programming when I was 18. There was literally no material I could read about system design. There was no way to learn system design from anyone else. We were all just starting at that point. It was the field was brand new. Nowadays, there is a tremendous amount of material on system design. You can read the works that I've written. You can read the works that Kent Beck has written and Martin Fowler has written and David Parnas has written. There is a wealth of material based on the mistakes that people like me made and learned not to do again. A wonderful book that I strongly recommend would be growing object-oriented software with tests. Growing object-oriented software with tests. It is a wonderful book on systems design. And I'll just leave that there. If you read that book, it's all done in Java. You read that book, you're going to learn an awful lot.
Okay, thanks for this one, and we will write the name. I just take a note about the book name. So I have one question, Robert, by the way, about you mentioned about cost versus scope of the change, and you mentioned about the honest estimate. So I'm really wondering, so you have a change, let me say, with a 1 sentence, 2 sentence. From that change request, how you can make a concrete estimation or a valid estimation, or how you can converge to a valid estimation with a 1 sentence request or 2.
Yeah, so right, the customers come to us and say, yep, we want to change it from Frabadats to Nabadats. And you're just sitting there going, well, geez, we've never done Nabadats before, but I don't know how long that's going to take. And what you don't want to do at that point is just throw out a number. That's 3 weeks. You don't want to do that. So what you're going to have to do is beg for a little time, say, okay, we need to think about this. Go off and do a work breakdown structure, standard technique, do a work breakdown structure, figure out what the big tasks are, figure out what the littler tasks are, figure out what the littler tasks below that are, do a little numerical analysis on that. You're going to be wrong. That's all wrong. Doesn't matter, right? You still have to do that. And then think, okay, this looks like about 7 weeks worth of work. If we've calculated it properly, if everything goes right, it's probably about 5 weeks worth of work. If everything goes wrong, it's probably 30 weeks worth of work. And you go back to them and you give them the 3 numbers. That's how you do it. It's always how you do it.
Okay, thank you. Also, I have one more question about automation testing. So assume you have an environment with lots of integrated applications. So is it efficient to run an automated test in that kind of environment? Because there may be some problems, issues on the other applications. So what do you think about it? What is the best practice for it?
Well, so you've got a large system built of many integrated applications.
Yes.
And how are you going to test that? First of all, you want to test each application individually. Mm-hmm. So, and that's much simpler, right? You just test each application based on their inputs and outputs. And you have to mock out or substitute out all of the other systems that it might be communicating with at the time. So you eliminate all the variables by mocking out all the other systems, putting in, replacement systems that are stupid, right? And then you can test the inputs and outputs of each individual application. That's called functional testing. And it can be easily automated. You have to do the work to write those mocks, to write the substitutes, but it's not very difficult to do. Then you go one layer up. One layer up is where you start doing integration testing. But you're not integrating everything. You start exploring 2 or 3 of these applications communicating together. And when you're doing that, the tests you are writing are particularly for testing the plumbing, making sure that the applications communicate with each other properly and that the dance of that communication is correct. You are not now testing business rules. Now you are just testing the architecture and the technical plumbing, right? And then you continue that process. You take it and say, okay, now let's bring some more of these applications in and bring some more of them in until you have the entire system. At each layer, those tests get more and more complicated, but there are fewer and fewer of them. This is a pyramid, right? So as you climb the pyramid, the tests themselves get more and more complicated and they take longer to run, but there are fewer of them. And by the time you get up to the top, it's really hard to run those tests, right? Because you've got the whole system integrated, and you have to do your inputs from the graphical user interface, and you've got to do the outputs by looking at reports. It's very difficult to automate that. At every stage up, It gets harder and harder and harder. Get the
Thank
architects
you.
involved, get the system designers involved, figure out how to do that in the minimal number of steps. I like to do that in like 2 steps, maybe 3, right? Until you get up to the top level.
Like divide and conquer, something like.
Divide and conquer, always divide and conquer. Yes.
Yeah, exactly. So, Robert, thanks for this great speech, by the way. Everyone is saying thanks to you. And I really like the last 3 parts. Say no, especially, it's really important. The continuous aggressive learning, it's really important. And I think one of the most important part is the mentoring. So thank you for this great presentation. It's really good to be with us. So host you here. So thank you and see you again soon.
All right. Thank you. Bye-bye, everybody.
Thank you. Bye-bye. Thank you, everyone, also.